Today we are going to build on our understanding of exponents with something called rational exponents, which is simply exponents that are fractions. So want to quick explore and regain some skills on our fraction math. So take a minute, try out all 4 of these fraction problems just to kind of recall how we do our arithmetic here. Go ahead and pause your screen and unpause when you're ready. Here's my quick explanations for all these. Problems 1 and 2, we are doing multiplication. So for this, we basically multiply straight across for both the top and bottom. So we get 2 times 1, and on bottom we get 3 times 4. There's going to be 2 over 12. And if we wanted to simplify that, we could expand it out and see that we have 2 over 2 times 6. 2's would cross out, and we would get 1 over 6 as our answer. Then for problem 2, again, we can multiply straight across. With the 3, we can assume that there's a 1 underneath. 3 divided by 1 is just 3. And again, we can multiply straight across. So in this case, we'd get 3 times 2 is 6 up top. 1 times 5 is 5 on the bottom. Moving on to 3 and 4, we have subtraction and addition for our fractions. And we need to remember that the denominator needs to be equal in order to solve these. So first thing I can do is kind of try to realize, hey, I need to get both of these denominators here equal to 6, specifically that 2. So in order to get 2 equal to 6, we can multiply it by 3, which means we also need to multiply by 3 up top. So we will get 3 over 6 minus 1 over 6. If we then actually carry out that, now that the denominators are the same, we can just add or subtract the numerators. So we get 2 over 6. And that would simplify down to 1 over 3. All right, last problem. Similar thing. This one's a little more complicated because we have to get 3 and 4 equal to each other. So we try to think, all right, what's the least common multiple that we can hit with those numbers? And the answer is 12. We are going to target 12 as our denominator. So on the left-hand side here, I'm going to multiply by 4 over 4. And what that'll give me is, let me go back here. What that'll give me is 8 over 12 on the left. And on the right side, if we multiply 3 over 3, that will give me 3 over 12 on the right. We can add those two things up now that the denominators are the same, so we get 11 over 12. So we are going to start applying our fraction skills to something called rational exponents. So quickly get down this definition and a couple of examples here. A rational exponent is simply an exponent that is a fraction. So if you look at these two examples, it's 9 raised to the 1/2 power, a raised to the 1/8 power. Both of our exponents are fractions in this case, which makes them what we call a rational exponent. So examples 1 through 6, we're going to just start simplifying expressions. Starting with examples 1 and 2, we're just going to take a number, raise it to a rational exponent with our calculator to simplify it. And we'll talk next week about mechanically what is happening. But I just want to gain this skill right now since we've been talking about exponent properties. So if you go into your calculator and you type in, so let me mark here, calculator, we type in 8, caret symbol, parentheses 2 divided by 3. That will give us our answer here. And if you type that in, we get, let me double check what I got here. 8 caret parentheses 2 divided by 3. We get an answer of 4. And it's really important here to hit those parentheses because otherwise we're going to take it to the power of 2 and then the calculator is going to divide by 3 after the fact. So try example 2 on your own, again using your calculator. Note the negative sign. Want to make sure we get practice with this as well. And when you unpause your screen to check your work, I'll have the calculator steps written out. We're going to go calc. We're going to go 64 caret parentheses negative 1 divided by 3 parentheses. And if I do that, we will get 0.25 as our answer. If we wanted to write that as a fraction, we can as well. That would be 1 over 4. All right, example 3, we're going to start applying our exponent properties to exponents that are rational, so our exponents with fractions. So example 3 here, we have our power rule where we're going to multiply these two things. So if I rewrite this, we'll go w to the 5th power times 1 over 5. Okay, those 5s will cancel out and we'll basically get w to the 1st power because we're just multiplying across with our fractions there. If I kind of zoom in on what that step looks like, 5 times 1 over 5, we get 5 divided by 5, which is just equal to 1. All right, try this on your own in example 4. I'll start walking through the steps as well. We get v raised to the negative 2 times 2 over 3. And let me kind of make this little side step here. If we do negative 2 times 2 over 3, we'll get negative 4/3. So my final answer here will be v to the negative 4/3 power. And if you wanted to write that without a negative exponent, you can write it in a really funky way. We can go 1 divided by v to the 4/3 power. But either way is correct there. All right, 2 more examples. Examples 5 and 6, we're going to be dealing with our product rule where we're adding or subtracting our fractions or our exponents. And so in this problem here, we have t to the 1/2 times t to the 3/2. So we are going to be adding up these exponents. So our base will still be t, and we'll get 1/2 plus 3/2 up top. Since the numerators are the same in this problem, 1/2 plus 3/2, we can just add straight across. We'll get 4 over 2, which we could simplify to 2, which means that our simplified version is t to the 2nd power. And one more example here with this application of the product rule. This one is a little odd because we have different denominators, but let's work through it just like we would. We can rewrite this x to the 5/4 plus 1/2. And I'm going to, again, kind of pull this fraction math here down below so we can see it. 5 over 4 plus 1 over 2. And we need to get those denominators equal to each other, so I'm going to multiply this second term by 2 divided by 2 in order to make the denominators the same. So we get 5 over 4 plus 2 over 4. And if we get that, we can start adding across. So we get 7 divided by 4 here as our exponent. And so our simplified expression is going to be x to the 7 divided by 4.